All right, so I guess we'll get started again. Hope you had a nice lunch. So this next presentation is about our FBX file format. It's a technology that all the media and entertainment products are using, and it also exists in some of the CAD products. So I'll just remind you about the ADN program. So FBX is also a technology that's supported through ADN directly. So if you do decide to use FBX, the ADN program can help you. So this class, we're going to talk about what FBX is and how it's integrated with the Autodesk products. We're going to talk about how you can connect your application or your pipeline to the FBX format. We'll talk about the pros and cons, the good parts and the bad parts about FBX and how it may fit in as a good solution for you. And then I'm going to show also the plugin extension SDK, which gives you some extra capability. So we'll go through these in order. We'll first talk about the considerations before choosing FBX. We'll compare that to real DWG, for example. We'll look at the overview of what FBX is. More specifically, we'll talk about the SDK, and then also the extensions SDK, and finally some additional information at the end. So let's talk about what considerations you should look at, what things you should consider before choosing FBX technology. Everything okay back there? Yeah, that would be good actually. Keep going. There you go. Good. So some considerations. So first of all, it is a 3D format. So you need to take a look at the modeling capabilities and make sure it meets your needs. FBX tessellation can be a problem, so it's something to consider. Materials, and we'll look at the Autodesk product workflows. So first of all, we talk about 3D modeling. So AutoCAD and Inventor, for example, are high precision modelers. The Autodesk Shape Manager, or ASM, is a manifold and non-manifold type of 3D geometry tool. It's typically using boundary representation for the visualization aspect of these models, more commonly called a solid modeler. So it's using the data for engineering purposes and has very high precision and accuracy, but it may not show visually in a realistic sense. So when you're rendering it, for example, tessellation could be an issue and that sort of thing. So this is typically stored in the DWG format. Inventor has its own format, but DWG is something that is used to exchange the data. So when we look at the media and entertainment products, 3ds Max and Maya, the data there is stored more generically as meshes and NURBS surfaces. So you get speed and visualization aspects, but the precision is not there. So if you need precision more than visualization capabilities, then you probably need to stick with the CAD formats. But if visualization, performance, speed in reading and writing the files are important to your pipeline or to your product, then FBX is a good choice. So tessellation is something to consider. So when you convert a solid model, for example, into a tessellated mesh, first of all, the conversion process has to do with settings such as the facet setting in AutoCAD. Depending on how you have the model faceted, may determine the precision of the resulting mesh that would go into FBX, for example. So it's something to consider even from the conversion standpoint to make sure your process includes the precision versus the realistic aspects. Also, when tessellation comes into effect, when you take a solid and you tessellate it into a mesh, it's not really round-trippable unless unless there's some data attached to it as well. So you kind of lose that ability to bring it back and make it a full solid model again. Another thing to consider is materials. So this isn't a great illustration, but the point is that materials can be used differently in different products. So in 3ds Max and Maya, for example, the idea of materials is primarily for visualization aspects. Okay, so when you apply a wood grain to a table, it's mainly to show that table as a wood-grained object. Whereas in a product such as Inventor, if you were to apply steel, there's engineering data that's also associated with that material. And you can use that same engineering data to put it through engineering analysis, stress analysis, that sort of thing. But the intent is more for engineering as opposed to visualization. So what's more important? So this is where the Autodesk Consistent Material Library comes into effect. Pretty much every product that has visualization capability, that has materials as something you can apply, comes with the Autodesk Consistent Material Library. So if you install Revit, 3ds Max, and Inventor, they can all consume from the same material library. So what this does is it gives you realistic and consistent visual materials. So the only difference might be the rendering technology. So rendering in 3ds Max, maybe using the third-party V-Ray renderer versus in Revit using the render in the cloud functionality. You still may get slightly different results just because the rendering technology is different, but the materials themselves, the source is the same. So this gives you common material definitions and a catalog to browse them. Custom visual materials can be created in the library, and what it provides is interop, the ability to preview these materials the same, and similar material UIs. Now the good thing about the Consistent Material Library is that those materials will also transmit through the FBX format. So if we take a quick look at the typical workflows, so Autodesk has been creating these suites of products. So no longer do you typically buy just one product. You might buy the building design suite, and you would get Revit and 3ds Max Design and a bunch of other products. So the workflows, we kind of separated into two categories. CAD data, which is typically using DWG to transmit that data. And on the entertainment side, FBX is used. Okay? So, for example, if you were to take a Revit model and bring it into 3ds Max, you would probably use DWG to do that. You could also use FBX. Okay? So these products are now supporting FBX as well, and that's what gives you kind of an advantage when working with media and entertainment products, because now FBX is supported across all of them. Okay? And you'll also notice that once you make it over to FBX, all of the suites are using it to transmit data, and that FBX data can also be pushed to the Autodesk Gameware products. Okay? So the suites themselves now have these what we call the one-click workflows. So for example, if you're in Revit, you can go to the one-click workflow. It's called Workflow, and you can click on a button that will take the model and transmit it to 3ds Max, for example, with one click. Okay? And so those workflows are typically now using FBX. So now, instead of using DWG to go to 3ds Max Design, typically that one click actually uses FBX and bypasses DWG. So if we look at FBX versus the DWG format, the only way you can work with DWG outside of the Autodesk products is to use an SDK called Real DWG. So this is the AutoCAD native file format. It's been around for many, many years. A lot of people have a lot of data stored in DWG format. It directly supports the Autodesk Shape Manager, so solid modeling, the manifold and non-manifold engineering type data is stored in DWG. It is Windows only. Real DWG as a toolkit only exists on Windows. Now the DWG format is compatible on the Mac, for example, and some of the other platforms, but Real DWG currently as an SDK is only supported in Windows. And it's also not free. Okay? In order to use Real DWG, you have to license it from Autodesk. And I don't know exactly what the business model is in China, but typically it's a subscription model. You pay Autodesk a certain amount of money every year to use the DWG SDK. Okay? So FBX, on the other hand, is completely free. You can go to Autodesk.com right now and you can download it. You don't even have to register. You can just go, right-click, download it, install it, and you have the SDK installed. But FBX is primarily working with mesh and NURBS data. So you automatically kind of lose this solid modeling capability. So that's the big difference. If you need this, you have to stick with DWG in the CAD side. If mesh is enough, then FBX is perfect. The other thing is animation is supported here. It's the media and entertainment data transfer format. So, of course, it has to support animation. It's also multi-platform. Mac and Linux SDKs are fully supported. But again, you have this issue of tessellation. You have this issue of losing the solid modeling data. Okay? So again, go back to consider whether accuracy or precision is important, or speed in rendering. You do get layered animation with FBX, and there's also these solvers in PhysX, which is part of FBX. So FBX is now supported with most of the major products. So AutoCAD has an FBX tool, Revit has it. Inventor doesn't have it built in, but there's a plugin you can get that will support FBX. So let's talk about what FBX is. So first of all, it's an open and free environment. This is how we like to promote it, as being open. The format itself can be published in an ASCII form. So you have the choice. You probably would use binary most of the time. But if you want to look at the structure, you can choose to export and import with ASCII, and then you can directly look at the structure of the file format itself. It's completely supported by Autodesk, so we have a Developer Center page called autodesk.com/develop-FBX, and there you'll find all the resources for support and help on FBX. It does include several utilities, so things that you can use that are pre-made. There's a file converter, an FBX file viewer, an Explorer, and a take manager. So where does FBX come from? So first of all, Autodesk's Motion Builder product is using FBX as its native format. So Motion Builder was a product that Autodesk acquired, and its original name was called FilmBox. So that's where the FB portion in FBX comes from. So Autodesk acquired FilmBox, we remarketed it, repackaged it as Motion Builder, and the FBX format was so robust that we made it our M&E platform interchange data format. So its main features are, of course, to support geometry. It does this through polygon meshes, NURBS, splines, instances, and references. So with these last two, what that does is gives you a little bit of performance. So if you have a very large scene where you have the same meshes being used over and over again to populate a scene with some detail, you can instance those or reference a core mesh, and it just saves data in the file itself. So it doesn't make the file too big. It improves performance. It fully supports lights and cameras. Textures and materials transmit through FBX. Deformations and bake information can be stored in the FBX. It does have a constraint system. Animation, rigging, and skeletons. It supports various units and has a layering mechanism so you can organize data as you want. And it does support embedded media. So, if you have a sound file, for example, that's meant to travel with the geometry and the animation, you can use the SDK to actually embed extra data into the file. So where is it used? In the third-party marketplace, a lot of our partners are using it for this idea of universal content delivery. So because FBX is open, it's not just Autodesk products that use them. And because it's free, anyone can use the FBX format and create models that can be consumed by Autodesk products and anything else that supports FBX. Okay, so this example is a company called TurboSquid, and they have just millions of different models that you can purchase from them, and one of the formats that they support directly is Autodesk FBX. So if you have a large pipeline in your company, and maybe you're using 3ds Max and Maya and maybe Softimage or some other tools, rather than having to get each one of those formats independently, you could purchase just the FBX format, and now it's supported through all of your products that handle FBX. Okay? It's also used for workflows. So this is a really good example. First of all, the 3ds Max product, since I think it was introduced in 2012, it has a built-in what they call the animation store. So you can go to a particular place and click animation store, and it will allow you to go online and purchase pre-made animations. So the company that's providing that functionality is called Miximo. Okay, they're a company based out of San Francisco, and they use FBX for all of their stuff. So you can actually take, for example, let's say a 3ds Max model, and you can export it to FBX, and then you upload to the Miximo tools, which is an online set of tools that's independent of any Autodesk tools, and they have these pre-made animation sequences that they also store in FBX. And what they will do is they will take your model, your geometry, and they'll take their animation sequences that are in FBX, and they'll merge them into a single new FBX file, and they will allow you to even preview that online. And if the animation sequence looks really good, say you want someone jumping into a specific move, and you like what they have to offer, then you can preview it, see if it fits your character, and if it does, then you can purchase it, and Miximo will then deliver you a final FBX that you can directly bring back into 3ds Max, and all the work is done. The animation sequence has been applied to your character. Okay, so it's a very cool system, and they pretty much do all this work just with the FBX format. So let's look at the SDK itself. So it is primarily a C++ based SDK. It's standalone, so you do not need to have any other Autodesk products to use it. It's a completely standalone SDK. Excuse me. It's multi-platform. It's also supported multi-version, and we provide release and debug libraries. So first of all, let's look at multi-platform. So you can see Windows. We support all the Visual Studio compilers. So it goes all the way back to 2005. I put a star on it because the 2014 release, which just came out, no longer is supporting 2005, but they added 2012, okay, Visual Studio 2012. So typically, it supports the three latest compilers from Microsoft. On the Mac OS and Linux, it's they're both using the GCC compiler. So the libraries are tested in that environment. When you get to Linux, we also specify where we test. It's not so rigid that you have to use those versions, but we tell you this is where we've tested and made sure that everything works fine. So we suggest using that environment, but it's not absolutely required. So the core part of the SDK is C++ based, but we provide a Python layer. We call them the Python bindings. And you can choose either Python version 2.6, which is the most popular version. So I think they're actually in the 2 series. They're up to 2.7 something now, and that will work. Or you can jump to the newer generation of Python, which is the 3 series, and we need at least 3.1 to support that. The only thing to consider here is that the Python bindings is kind of a wrapper around the C++ SDK. And almost everything is exposed to Python, but not everything. So you should probably take a look and evaluate if you need to use Python. Make sure everything that you need is in the Python SDK before you choose it. The documentation is pretty good. It will show you in the Python section. It shows you all the classes that are exposed to Python. So you can compare that to what's available in C++. So let's do a short demo here. Let's see. Okay, so these are, this first one is a sample that includes full source from the SDK. They're using OpenGL as a visualization technology. So let me just run this. So right now it's reading in the FBX file. This FBX file is one sample that's included. It's a little dark. I'm sorry you can't see it perfectly. But it's a pre-made one. It has animation showing this character moving around and getting shot, basically. So the cool thing about FBX is that it is a full 3D environment. So what you can do is you can view things differently. So let's say we want to look at this FBX file from the top. So we just switch the viewing angle, and we can see the same animated sequence that way. I can go to switch to the camera view, and now we're looking at it from the camera that was in that scene. Okay, and because this is a 3D format, we can zoom around. Let's see if I can get this to work. Oh, I need to switch to a different camera, I think. Oh, it's not working quite right. But you could, because it's full 3D data, you can zoom around and you can look at it in different ways. So this is a sample where the full source code is provided. It's using an open source OpenGL tool to do the visualization. So you can see it's completely independent of any of the Autodesk technologies. It's using primarily FBX itself to view it. So let's take a look at what kind of code you would do. So I'm going to debug a tool that we wrote for an FBX training that we had last year. So this is just a simple console application, but you can see that basically you need to start off by getting an instance of the FBX manager class. Okay, so there's a global that you just call to get an instance of this class. From there, you start creating the different types. And so the creation techniques is very similar throughout. So to create a scene, FBX scene, create, and you need to provide it your manager instance, and then in this case it's a name. All right, so let's step through this. So I've got the manager, created a scene. So now the scene will contain all of the data. So in order for something to belong to the scene, you have to create a node for it to be attached to. So what we're going to do is we're going to go to the scene, and we'll get its root node, so the top node that everything else is going to belong to, and then we can start creating things in that node. Okay? So I can create a camera. So let's step into this. And you can see here it's the same idea. I go to the camera and I say create, and then I can set data. So the SDK is very well formed, and it's pretty easy to work with and figure out what kinds of things you would need to do. All right, so I'm setting up the camera, and then a camera typically has a direction, so you need to also create a target for the camera to look at. So I'll create the target. And then what I'm doing is, after I created those, the camera with the target, I'm going to return the node back to the calling function. And then I can take that node and add it to the root. Okay, so I'm going to the root saying add child. So this is basically inserting the camera into the scene. All right, so the same for the light. I'll just step over this. So we'll create a light. There's also the ability to add custom data. So in this example, we're creating some user properties, and we're adding our own data to the FBX file as well that wouldn't be storable in any of the normal objects. So this gives you the ability to create your own data and store it with the objects in the scene. So let's step over that. This section here is doing some work with connections. So the scene itself is set up with automatic connections or relationships. So the root node is at the top of the graph. And when you add a child, like the camera, to the root node, there's automatically a relationship created. Let's say I added the light, and I want the light to have a relationship to the camera as well. But normally I would just create that as another child of the root. And what I can do is I can set up my own relationships as well. So I can say, well, this light is also related to this camera, and they have to be together. And so when I'm interpreting the FBX file later, that relationship can be found very easily. Okay, so there's a direct, what they call the connection API. So the next one, let's step into this, and we can create some geometry. So this is creating a cube. And so what I'm going to do is I'm going to set up some points to represent the vertices. I'm going to set up some normal vectors so that the faces that I'm creating have the proper normals. The vertex indexing. So face number 1, for example, is from the vertex 0, 1, 2, and 3 to create that polyface. The next face is 1, 5, 6, 2. So this is the vertice indexing to define the faces. And then I go and I create a mesh. And I have to initialize the points in the mesh. And here you can see I'm using the number of faces times the vertex per face to create that control point. And then I basically iterate over that mesh, creating the polygons that are going to define 3D geometry. Okay. We can then store the normals on a layer, so the data is attached to the mesh, but it's organized in a certain way so that it's independent as well. So you can process it how you want. And let's see here. So this is the normals. All right, and then so the last thing we do is we create a node that that mesh is going to be attached to so that it can be added to the scene. Let's step out of here. So the next thing let's look at is materials. So we'll step into this one. So what we're going to do here is we're going to basically create a new material, and we're going to create a material for each face independently. So basically we want a material for each side of this cube to be independent. So we can walk through the material and create a new material and assign some specific values to the material, and then finally we add the material to the cube. Okay, and it's all about the indexing in terms of which material is assigned to which face in the cube. And let's see, the next thing I'll run here. Okay, so the last thing we'll do is we'll animate the cube. So the first thing we have to do here is, if the scene is a new scene, we have to create what's called the animation stack. So you can have different animation curves in a stack, and then each curve gets its own layer. And then the animation curve itself we set up, and we can set keys in the animation, and then for each key we're going to set different values and different interpolation modes. So animation is created through this curve mechanism, and it gives you a lot of capability. The animation curve idea translates well to both Maya, 3ds Max. So it's a kind of a common idea. So let's step out of here. And so what we've done now is we've created all of this data in memory. It's in our FBX manager. And the last thing we need to do is we need to write that out to a file. So we do all this work in memory, and then we say, okay, now we're going to export it to a file so that it can live on disk. So I'll step into this one. And with the import and export facility, we call this the I/O plug registry. So the registry itself for the SDK stores the different types of import and export. And typically that means just binary and ASCII format. So binary is the default. So if you want to export to ASCII, you have to do a little bit of extra work. So if we go here, find ASCII file, you can see we go to the I/O plugin registry, we get the native writer format, and then from there we simply look to see if the ASCII formatter is installed, and it should be, but this allows you to configure the SDK how you want. So if you're delivering it with your product and you don't want people to write ASCII, you can take that out in your delivery mechanism, and then the person can only export in binary. Okay? So that kind of protects the structure of your FBX file if you want to as well. So the only way they would be able to actually look at the structure of the FBX is to import it into another product, which could change the data, and then export it in ASCII. So it gives you some control over what people do with the data as well. And then we need to clean up, and that will create the file. So what I did was I just kind of output the node hierarchy. So the source objects, this is showing the connection mechanism. So the camera node, the point light are source, and the destination is the ADN scene. So these are relationships that I've set up that are important to me. FBX doesn't really care about that because they all belong to the root part of the scene anyway. But when I'm interpreting the scene in my product, I can say, oh, these two source objects are connected to that scene in a certain way. So it gives me a little bit of control over relationships between objects. And then you can see some additional types of connections here that I just artificially created for this sample. All right, so that created this file called output.fbx. So let's just take a quick look at this format. What's going on here? So when I output to ASCII, I can directly open the FBX, and I can look at the context. We don't publish the format itself because using the SDK, you can create these relationships, all of that. So the format is technically up to you. The base relationships, a camera node belonging to the scene, for example, those are given. But anything else that you want to do in terms of relationships between objects are up to you. Your animation curves, all of that. Okay. So when you're working with the SDK, a trick to get in the habit of doing is as you're coding your FBX format, use the ASCII format for the import and the export, and then you can open it up and you can see how things are structured and kind of see how the API code created the structure in the FBX file itself. It's also very useful to use Maya or 3ds Max's export and change the setting to ASCII so you can also see how they export their file. And if you're trying to create something that's really highly compatible with Maya, for example, you can take example models, export them out of Maya into FBX ASCII, and look at the exact structure that Maya's plug-in for exporting FBX, what that format looks like. Let's see. So let me just run the sample for Python as well. So I'm not a Python wizard, so I'm not going to show a lot here, but I've got an instance of Python running, and all I did was I called my Python instance on this sample that's included in the Python SDK. So export scene 01. And when we look at that code, you'll see very similar structures to the C++ SDK. So for example, to create the scene, it's the same idea. You use the object type .create to create the type. So working between Python and C++, the ideas are the same. So if you look in the samples and you don't find a Python example that's exactly doing what you want, but you do see the C++ one, you can kind of use that C++ code to, to create your Python code. So the constructs are very similar. And we have 3 different SDKs. So first of all, there's the FBX SDK, which is the C++ system. You can get that in the Windows, Linux and Mac formats. They're independent, so you download the one you need. And then there's the Python SDK. So that's a separate download as well. And then the third one is called the FBX Extensions SDK. So what Extensions does is it kind of solves an interesting problem. It basically allows you to customize the import and export from our products. So if you don't like the 3ds Max export that's default, you don't like it exactly, what you can do is you can use this extension SDK to let 3ds Max export in its default format for FBX, and then you can intercept, oh, I'm done exporting from Max, do you want to do anything? So it's like a callback mechanism. And if you say yes, it gives you the ability to modify the FBX before the process is finished. So you can actually customize our versions of FBX and how we import and export. So basically you find these entry points to hook into the import-export process. There's a bunch of samples that allow you to read and write in a custom file format. And there's the extensions the SDK includes extensions to all three of our main products, 3ds Max, Maya, and Motion Builder. So more specifically, what this problem what this solves is the idea that, before FBX Extension SDK came along, in order to get a proprietary format, you typically would write your own plugin exporter. So whatever, you wouldn't be using, you'd be basically creating your own export format. So the advantages there is, of course, you have full control over it, but the disadvantages is it may take a lifetime to get it right. Doing import and export of data is a lot of work. So you have to do all the work yourself with this approach. So the off-the-shelf approach is that basically when you install Maya or 3ds Max, it has FBX export. So it's free and it's supported and you don't have to do anything. But the disadvantages are basically that you have no control over what goes into the FBX. So if you have your own custom data that you're writing into a Maya scene and you need to translate that scene through FBX, you're probably going to lose that custom data. Okay? So you're relying on the FBX default format, and the default plugin doesn't know anything about your custom data. So this extension SDK kind of solves that problem. It allows you to invoke your code during the import and export process, so you don't have to worry about the format that Maya is using, for example. All you're doing is you're kind of adding to that format. So it gives you the best of both worlds. So basically the Autodesk plugins provide the default state. It's highly customizable. We have documented it very clearly, and we provide source code, and it's supported by Autodesk. So if you need to use this mechanism, you can be assured that going forward in time, we're going to continue to support this idea. So let me just show you a quick example of how this works. So I've got a 3ds Max scene loaded here, and there's basically 3 pieces of geometry. And I'm going to export this to FBX. And what I've done to kind of save a little bit of time is I exported it before I installed my extension plugin. So I've got basically the default FBX format that 3ds Max created. And I'm going to create a new file called after, which is going to hook into my plugin. So it takes me into the default FBX plugin. Okay, so these are all the things that are provided by 3ds Max. And the only thing I changed was switching it to the ASCII format so we can look at the data. So I'll go ahead and say OK. And you can see it jumps into my running plugin. So the default 3ds Max FBX plugin is now calling my plugin and giving me a chance to do something extra. So there's different entry points. So you can choose to enter at the export begin. There's an export translated. There's an export process, and that's the one I'm using here, which is basically for every object that's getting exported, here's the object that we are working on in the Max sense, and here's the object that it got translated to in the FBX sense, and do you want to do anything to that data? Okay. Some of the other ones, you can do the export at the end, so you can trap the end of the export and add some extra data to the end of the file. And then there's also similar hooks for the import methods. So let's take a look at what we're doing here. So what I'm getting passed in is the FBX object. So this is what it was translated to. Okay, this is the FBX version of the object that's being exported. This happens to be a 3ds Max SDK type, reference target. In Maya, it would be the Maya's type. So it's going to get called for every object in the scene, and I can do something to that. And it's also providing me with the FBX scene itself. Okay? So the reference target is a generic type in 3ds Max. So what I can do is I can directly cast that to a more specific type. And if it's the type I want, then I can step in and do some things. So in this case, I go and I get the object associated with the 3ds Max node. I'm converting it to an internal 3ds Max type. So this is using SDK, 3ds Max SDK functionality. And in this case, I'm going to get the number of vertices on the mesh. And this is the max data. And then what I'm going to do is I'm going to create a custom object, and I'm going to store some vertex data per mesh. And then I'm basically connecting that vertex data back to the new FBX object. So I'm creating my own relationship as well. So my custom data with this vertex data is now associated with the FBX object that holds the mesh data. Okay? So let's just go ahead and run this. So if you remember, the scene contained 3 nodes. So it's going to hit this 3 times. And then it finishes writing the file. So let me show you basically what it added. So what I have here is the ASCII format of the file before and after I added my data. And you can see that it wrote a new file, so I'm going to reload that new file on the right side. So this is a differencing tool. So this is the data as it was written by 3ds Max without my extension plugin. And this is the data that was written afterwards. Now at the first part of it, you're going to see a few differences which just have to do with the timestamp, because I exported at different times. All of the unique identifiers in the file are going to be different because they're 2 separate FBX files that got created. So these first few differences are to be expected. But here's one that's new. This block here, the object type. So this is my custom object type that I created to hold the data. And there's basically 3 pieces of data in there because there were 3 meshes that I processed. So I created 3 of these types to hold the vertex data for each one of those meshes. This data is just telling the FBX file that there is some extra plugin data in the file. So this is going to be present all the time. I'm really sorry. I tried to do that, and this tool doesn't zoom. So I'm sorry about that. But I think this is still the easiest way to see the new data. So these are all ID differences. And then when we get to this section right here, this is all my new data. So if you remember, I was creating vertex data for each vertex. So the first one was a box, so I have 8 vertices. The second one was the prism, so there was 8 vertices there. And the third one was the pyramid, and I have 6 vertices. So this was just kind of made up data, but this could be any data you wanted. Okay, any custom data. Maybe you have some custom shading mechanism and you want per vertex color data that FBX doesn't support, and you want to store that separately. So all of this data was added, but it's just kind of extra data. It doesn't, at this point, it's not really connected to anything. So that last part where I was connecting the source objects to the FBX objects, you can see now I have some extra connection points too. So this is the section that defines the relationships in an FBX file. So now this last one here was geometry, which is the model of the pyramid. So you can still see that there. The extra pieces are the model of box 01 is now connected to my custom object instance of box 01. So when I'm reading this back in, I can say, oh, here's a connection to my custom data, and at the time of read, I can go and get that extra data, and it makes it very convenient to grab the data that you need, and it's associated with the objects you want. All right, so the FBX SDK is something that we have a strong commitment for. It's updated regularly. We continue to support the multi-platform. The extension SDK is provided with each release of the FBX SDK. We provide archives for older versions. So if you, for example, decide on using FBX 2012 or, I don't know, 2013 as your pipeline format, we maintain that version, and if for whatever reason you need to have a new instance of that SDK, you can go back into the archives and you can get the older versions as well. And it's always provided as a free download. You don't have to register, tell us who you are, or anything like that. You can just download it and it's free. The FBX tools as well. So each one of the products has an FBX import and export plugin. And those can be updated independently of the product as well as the FBX format. So if you want 3ds Max 2014 to support the 2013 version of FBX, you can go backwards. You can go forwards. Okay, so the release cycle is basically independent of the product releases. And again, the tools themselves, we have the older versions available, and these are also free. So the plugin, when you go into 3ds Max and say export, if there's a newer version, it will tell you, and you can get those newer versions for free as well. So some resources for FBX. We do have another forum on the area site. There's a blog that Christopher Diggins creates, and that does have some information about FBX. And then the online documentation is probably your best bet. From an ADN standpoint, we do have a developer page, so it's autodesk.com develop FBX. So all the resources that we have available for the SDK are listed on this page. If you're really interested in it, I did a 5-day training, a 5-hour training last year that you can download, and it contains detailed introduction to the FBX SDK. If you join ADN, we support FBX as well. So it's a free tool, but we recognize that if you're a professional developer and you need help, we will support it directly through the ADN program. Okay? And that's it. So we have some time for questions. Is anyone using FBX already for any part of your pipeline or workflow? Yeah? So do you use it as an export format from one of our products already, or do you use the SDK directly? Great. Good. You're using it as well?
I want to test it, or I actually used it.
Yeah.
Because we still have other formats that I like it.
Yeah.
I want to ask you one thing. FBX store the animation. What's the way store animation? It is store the quantum cloud every way, or just store the animation curve.
You can do both. So you can store the animation curve, or you can bake the animation directly to your mesh if you want and prefer that. So it's your choice. When you're writing using the SDK, there's different API techniques, and we have examples of both that would allow you to choose how do you do it. The plugins themselves also have configurations. So, for example, if you look in 3ds Max, when you say export this section right here, animation, you can choose to include it or not. And then there's also different ways of including it. So like there's a section here that says bake animation, and if you check this, then it's going to bake it across your timeline that you choose. Okay? So it's pretty flexible, and the SDK would allow you to access it in either mechanism as well. Yes. Yes. And there you have the choice of baking the material to the mesh or not. By default, the material is stored separately, and if the material is referencing multiple meshes, you only have to store it once. The only difficult aspect with materials is that if you're using the Autodesk Consistent library, those materials, because they're part of Autodesk intellectual property, they don't allow you to get the details about the material. So we encrypt those materials in the FBX file, and you can see, for example, the name of the material, but you can't get the details of the material itself. So that's just one limitation. But if you're not using the Autodesk Consistent Material Library, then you have full control over that as well. Only animation? Yeah. 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 That's exactly what Miximo does. They store just the animation with certain rigging points, and then they can apply that animation to any other model if you have the same rigging points set up. So they basically just overlay it, and then they will actually combine it into a single FBX and show you a preview of it. And so it's a very enticing way for them to market their animation to you as a user. And if you like it, you can say, yes, I'll buy it right then and there. So it's a good system. I would suggest looking at Miximo's website if you're interested in that idea, because they have a really good workflow, so you can kind of see what's possible. Yeah. Yes. Any other questions?
Film company, China Film Group. One thing is the China Film Group.
Fantastic.
Yeah, they have a dedicated developer team, around 10 developers. Most of them are very young, very new department. So how long you are working in the company?
Yeah. Great. Fantastic.
So before you join this company, you already have some experience in the development, the M&E. What's your background for the, you are the programming background or your M&E user background?
Yeah. One thing that could be really helpful for you. Are you already an ADN member? Do you belong to the ADN program?
They are already ADN members.
Fantastic. Because with the ADN program, you can get licenses for all of this technology. So 3ds Max, Maya, Motion Builder, and use those for development. So it's a really good way for you to experiment and see what's possible using our products without having to buy a license for everything. Yeah, it's a very, very good program.
Also a big customer.
Yeah.
But they are not also developing, they are manufacturing.
Ah, great. That's a good sign.
Very few in China.
Yeah, well, I mean that's another fantastic benefit of the ADN program is the membership level cost is pretty low, and from a development standpoint, you basically can sample all the products and work with them from a development standpoint.
I got some comments for you. Actually, you can leverage ADN program cut your budget software cost. 没有那种可以用 ADN 这种 program 来减少你的而且 ADN 呢，实际上是每年都有一个更新的，而你没有如果说要这么做，只要你给到你不要不信，就不需要做。而且这种也不长，你们10个人都是你看它10套，你不但需要卖，需要卖，需要模型丢的，需要其他的。这个
Any other questions? Okay. All right, so we'll take just a short break, probably maybe 10 minutes, just for my colleague to come back, and he's going to be talking about Maya for the next 2 presentations. All right. Yep. Let me just stop this real quick.